Hey guys, welcome to your first video for this new unit. This is 5.1 graphing growth. So we want to know, well, what is exponential growth? That's just growth that increases by a constant proportion. So a lot of times we hear about this with money. So this example I'll read in a second is about money. Once you kind of figure out what exponential growth is, we'll focus on graphing today. And then in your third video, you'll learn about how we use it with money. Example, a father complained that his son's allowance of $5 per week was too much. The son replied, "Okay, Dad, how about this? You give me a penny for the first day of the month, 2 cents for the second, 4 cents for the next, 8 cents for the next, and so on for every day of the month." The father readily consented. Who was more clever, though, the father or the son? Hopefully you can tell from this picture here that the son was more clever, right? Because at the end of the month, his dad actually owed him $10 million, right? Or $10.7 million. That's quite a bit of money, right? So he was getting paid at a constant proportion, right? It was doubling every single day, and it grew really, really fast. Okay, so today we'll be focusing on graphing those. So you'll see how the graph looks when things are really growing very quickly. So just a quick review from what you learned 2 units ago. The parent equation for an exponential function is y equals ab to the x minus h plus k. What does that b mean? When you have an equation of the form, y equals b to the x, that helps us to determine, that's the most basic form. Sorry, I'm just erasing the stuff we don't want that. When you have an equation of this very basic form where you just have y equals b to the x, so like for example, y equals 3 to the x, your y-intercept is always 1. Always, always, always. Okay? Your y-intercept will stay as 1 unless you have something happening with your a. Okay? The a transforms your graph and it gives it a new y-intercept, and it's at 0, a. Okay, so your y-intercept is at that a value. You'll see what I mean in an example. And then h moves the graph from left to right. K has 2 jobs. It moves your graph up and down, and it helps us to locate your horizontal asymptote. You'll see what I'm saying when we look at these examples. Okay, so let's dive right on in. This first one here, we're looking at y equals 3 to the x. That's awesome. That's in the most basic form. We know exactly where our y-intercept is, right? It's at 1. Okay? But we want to find out a couple other points, right? So we can make this graph. A good way to do that is to make a table. You can also use Desmos. I will not stop you from doing that, okay? Because you will have technology at your fingertips. And so if you want to use Desmos, please do. Let's just choose some points. Let's do like -1, 0, 1, and 2. Well, we know already when x is 0, that's where our y-intercept is, right? 3 to the 0 is 1. Anything to the 0 power is 1, right? But what about, let's see, what if x is -1? That's 3 to the -1 power. That gives us 1/3. 3 to the first power gives us 3. And then 3 to the second power gives us 9. So you can see how quickly this graph is growing, right? So -1 is at about 1/3, so right there-ish. And then we've got 1, 3, 2, 3. And then we've got 2, 9. And that's way, 9's up here somewhere. The other thing to know is, where's that asymptote? If you don't have things shifting up, then your asymptote is going to be at that y-axis here. So right here is where your asymptote. Your graph never crosses this line here. Never crosses. Okay, so we're going to try and draw it. It'll get really close to it, but it doesn't cross it. Okay, so that's what our graph looks like. It grows really fast. You can see how quickly it rises. Okay, and then if you want to check out Desmos, you absolutely can. We'll put our asymptote equation on there. When we have horizontal lines, that means y equals that number, which is at 0. Let's look at the other graphs here. This one, now it has an a value. So instead of our y-intercept being at 1, it's now moved up to 2. Okay, so y-intercept is at 2. Let's make a table for our other values. So x and y. Let's do like -1, 0, 1, and 2 again. We just need a few points so that we can kind of get the shape of it. So when x is -1, that means we have 4 to the -1 power, which is 1/4. And 1/4 times 2 is 2 over 4, or 1/2. Okay, 0, that's our y-intercept, right? When x is 0, our y-intercept is 2. What about when x is 1? We've got 4 to the first power, which is 4 times 2, which gives us 8. And then, lastly here, 4 to the second power is 16 times 2, which is 32. So you can see this one, this one is growing really fast. So at -1, we have 1/2, so like right here. And then 1/8, which is at the very top here. And then 2/32, which is way up there. Okay, and then just like I was saying with that asymptote, if you don't have any sort of vertical shift or that k value, it's at x equals, or y equals 0. Okay, and then let's draw that graph. It never crosses that asymptote. It'll get really close to it though. So we'll draw it the best that we can, and then this graph really grows fast. Okay, and then trying to keep these videos a little bit shorter for you guys, so we're not going to switch to Desmos. If you want to ask me in class to look at them together, if you want to look at them, you are more than welcome to. All right, this next one, we got a little bit more happening here. So we've got a horizontal movement and a vertical. So from 2 units ago, we should know this. We have x plus 1. That means we're shifting left 1. And then we have this plus 3 here. That means we're going to shift up 3. So start with where our y-intercept always is. Okay, it's always at 1 from the very basic form. Now let's move it. Okay, so we're going to move it left 1. So that would be there. And then up 3. 1, 2, 3. So that is where our graph is really going to be. And we don't know our y-intercept yet, right? Because it's not crossing. We don't have a point on that line quite yet. So let's make a table. We've got x and y. Let's do, since we're already at x is -1 with that first point, let's do a -2, -1, 1, and 2. So when x is -2, we have 2 to the -2 plus 1. -2 plus 1 is -1. So that means we have 2 to the negative first, which is 1/2, plus 3 gives us 3.5. And then we have our -1 value, which we see is at 4. And now let's find our y-intercept. We have where x is 0. So if x is 0, we have 2 to the first, which is 2, plus 3, which is 5. Okay, and then, oh, where'd it go? There we go. And then we have when x is equal to 1. So 2 to the 1 plus 1 is 2. So 2 squared is 4, plus 3 is 7. And then the last one here, so we have 2 to the 2 plus 1, so 2 cubed, which is 8, plus 3 is 11. All right, let's graph these points. So at -2, we're at 3.5, 2, 3, so right here-ish. And then -1, 4 we already have, so 0, 5. So we finally found our y-intercept. And then 1, 7. So 5, 6, 7. And then the other one's pretty far up there. All right, and then this is where I was saying where your k has multiple jobs. Your k told us to move our graph up, but it also is telling us where that asymptote is. Our asymptote is at 3. Y equals 3. Okay, so we draw our little dotted line, and then we can complete our graph. It's never ever going to cross. It'll get really close. Okay, so then let's add, we've got our y-intercept at 5, and our asymptote is at y equals 3. Okay, final example here. Again, we've got a horizontal shift and a vertical shift. Okay, so this x minus 2 means we're going right 2, and this negative 1 means we're going down 1. Okay, so start from the beginning. Where is our y-intercept normally? On the very basic level, it's at 1. Now let's move it right 2 and down 1. So right 2 and down 1 is right here. So that's where we have our graph. Okay, 1 point on our graph. Let's make a table to find the rest of the points. Or find a few points and then we can graph it. So let's do like negative 1, 0, 1, 2, and 3. How about? So if x is negative 1, that means we have 3 to the negative 1 minus 2. So we have 3 to the negative 3 power. And that gets us 0.037037 repeating. And then we subtract 1. So we get negative 0.96. Okay, so kind of ugly numbers with that one, but that's okay. We just know it's really close to negative 1. And then, let's see, when x is 0, we have 3 to the negative 2 power, which is 0.111111 repeating. And then subtract 1 to finish out the rest of that equation, and we get negative 0.8889. How about? And that's our y-intercept. Kind of ugly, but we know it's a little bit higher than our last point, right, at that negative 1. What about when x is 1? We've got 3 to the 1 minus 2, which would be 3 to the negative 1. So then we have 1/3 minus 1 is negative 2/3, or 0.67. And then when x is 2, we already have that, right? When x is 2, that means we have 3 to the 2 minus 2, which is 3 to the 0. 1 minus 1 is 0. That's why we're on that x-axis there. Final one we'll do, we have 3. So 3 to the 3 minus 2. So 3 to the 1 is 3, minus 1 is 2. So let's graph those points. So at negative 1, we're really close to negative 1. So kind of there, I would say. And then at 0, we're at negative 0.8889. So that's probably like here-ish. And then at 1, we're at negative 0.67. So that's like there-ish. And then at 2, we're at 0, and then at 3, we're at 2. So 2. So it's starting to rise up. Okay, and then, there we go. And then let's do our asymptote, which is our k value. It's at negative 1. So let's draw our dotted line. Okay, and then our graph will get super close to it, but never crosses it. And then let's write down here, we've got our y-intercept at that ugly number, 0.8889, and then our asymptote is at y equals negative 1, right? That dotted line. Okay, that is it for this video. Please let me know if you've got any questions at all.